Picture a moment frozen in time, a massive, gleaming spacecraft hovering silently above Earth, casting an eerie glow over a crowd of stunned onlookers. You've seen it in movies, right? That spine-tingling scene where humanity comes face to face with something beyond our world. But what if it wasn't just Hollywood magic? What if tomorrow scientists picked up a signal clear, unmistakable, and undeniably alien? That moment wouldn't just rewrite history. It would throw us into a whirlwind of questions we've barely begun to answer. Are we prepared for first contact? Who speaks for Earth? And what happens when the greatest mystery of all time stops being a mystery? This isn't just science fiction anymore. Right now, telescopes scan distant stars, listening for whispers of life. Rovers dig into Martian soil, hunting for fossils of long-dead microbes. Governments have drafted secret protocols, yes, real ones, for what to do if we're not alone. The truth is, we're closer than ever to answering the ultimate question. Are we the only ones out here? But here's the catch: discovery is just the beginning. The real challenge, figuring out what comes next. How do we talk to a species that might not think, communicate, or even perceive reality the way we do? What if they're nothing like the little green men we've imagined? Think about it. For centuries, we've wondered, dreamed, and feared what's beyond our planet. But the universe doesn't care about our fantasies. It doesn't owe us friendly neighbors or wise interstellar mentors. First contact could be peaceful, or it could throw humanity into chaos. That's why scientists, diplomats, and even the United Nations have spent decades crafting plans for this very scenario. From radio messages to quarantine protocols, from cultural contamination, risks to the mind-bending math of interstellar diplomacy, every detail matters. Because one day, maybe sooner than we think, fiction could become reality, and when it does, we'd better be ready. So let's ask the big questions. Let's dive into the science, the politics, and the sheer wonder of what it would mean to finally meet the cosmos. So why haven't we found them yet? That's the heart of the Fermi Paradox, a puzzle that's baffled scientists for decades. If the universe is so vast with billions of stars and planets, where is everybody? Even conservative estimates suggest there should be thousands of civilizations out there. Yet our telescopes hear nothing but silence. It's like throwing a party for the entire galaxy and realizing no one showed up. One explanation is the Great Filter, a kind of cosmic bottleneck that stops life from reaching the stars. Maybe it's lurking in our past. Perhaps the leap from simple cells to complex life is so improbable that Earth got lucky. Or worse, what if the filter is ahead of us, a fate so catastrophic that every civilization hits a wall before they can spread beyond their home planet? War, climate collapse, runaway AI, any of these could be the universe's way of hitting the reset button. Then there's the zoo hypothesis. Imagine aliens watching us from afar, deliberately staying hidden like scientists observing animals in the wild. Maybe they're waiting for us to reach a certain level of maturity before making contact. Or maybe we're just not interesting enough yet. Think about it. Would an advanced civilization bother talking to ants? And let's not forget the simplest answer. We might truly be alone. The conditions for intelligent life could be so rare that Earth is a fluke, a tiny oasis in a desert of dead worlds. The Drake equation, a formula that tries to calculate the odds, is filled with unknowns. How many planets are habitable? How often does life arise? How long do civilizations last? Each variable could shrink the number of possible neighbors to zero. But here's the twist: the paradox itself might be an illusion. Our search has barely begun. We've scanned a fraction of the sky, and for all we know, alien signals could be drifting past us right now, in a language we don't yet understand. The universe is old, and we've only been listening for a blink in cosmic time. So while the silence feels eerie, it might just be a matter of patience or learning how to hear what's already out there. Humanity has been reaching into the cosmos long before we had the technology to listen for a reply. Back in the 1800s, mathematician Carl Friedrich Gauss proposed carving giant geometric shapes into Siberia's forests, a visual love letter to hypothetical Martians. Then came Nikola Tesla, who swore he'd intercepted alien radio signals in his lab, though history now chalks it up to experimental error. These early dreams weren't just quirk, they were the first sparks of a burning question. If we shout into the void, will anything shout back? Fast forward to the 20th century and the efforts got bolder. In 1974, the Arecibo telescope blasted a 3-minute radio message toward a star cluster 25,000 light-years away. Crammed with binary code, DNA diagrams, and a stick figure human, it was like a cosmic postcard but with one glaring problem. By the time it arrives, the cluster will have drifted away. Critics called it futile, even reckless. Why announce ourselves to a universe we don't understand? Then there's the Voyager golden record, humanity's most poetic attempt. Attached to both Voyager probes in 1977, these gold-plated discs carry greetings in 55 languages, whale songs, and even Chuck Berry's Johnny B. Good, they're time capsules really meant to outlast our civilization. But here's the irony. Even if extraterrestrials stumble upon one, they'd need a record player and a map to decode the symbols etched on the cover. Today, projects like METI messaging extraterrestrial intelligence double down on active outreach, beaming tightly focused signals at nearby stars, but not everyone's cheering. Prominent scientists, including Stephen Hawking, warned it's like lighting a bonfire in an unknown jungle. What if we attract something indifferent or worse, hostile? Others argue silence is paranoia. After all, any civilization advanced enough to visit us would have already noticed our TV broadcasts and radar pulses. So why keep trying? Maybe it's not just about them. Every message we send forces us to define what humanity is, what we value, what we fear, what we're proud of. The Golden Record didn't include wars or pollution, it showed our hopeful side. In a way, these attempts are mirrors, revealing who we hope to be when the cosmos finally answers the phone. While humanity has been sending messages into the cosmos for over a century, the real work of listening for a reply falls to SETI, the search for extraterrestrial intelligence. Picture arrays of massive radio telescopes scattered across the globe, their dishes tilted toward the stars like giant ears straining to catch a whisper in the dark. These aren't looking for natural cosmic static pulsars or distant galaxies. They're hunting for something far more elusive, a signal that doesn't belong. A pattern, a structure, something that screams artificial. The most famous blip in SETI history came in 1977, when astronomer Jerry Amon circled a sudden spike on a printout and scribbled "wow." Next to it, for 72 seconds, a radio telescope in Ohio picked up a narrowband signal 30 times stronger than background noise, coming from the direction of the Sagittarius constellation. It matched exactly what scientists predicted an alien transmission might look like, but then it vanished. Decades of follow-up scans found nothing. Was it a glitch? A passing satellite, or a fleeting hello from a civilization that didn't stick around for small talk? The wow signal remains a tantalizing mystery, proof that the cosmos knows how to keep us guessing. The challenge isn't just finding a signal, it's recognizing one in the first place. Space is loud, cosmic radiation, pulsars, even our own satellites create a cacophony of interference. SETI algorithms sift through millions of frequencies every second, filtering out the noise like someone trying to hear a single voice in a packed stadium. And then there's the question of what we're even listening for. Would an advanced civilization use radio waves or something we haven't invented yet? Quantum communication, neutrino beams, or technologies we can't even name? Some scientists argue we might be missing the messages already. Imagine an alien race sending updates in bursts like cosmic text messages instead of a continuous broadcast. Or what if their signals are compressed, encrypted, or encoded in a way we haven't cracked? It's like trying to read a book in a language that doesn't exist while wearing noise-canceling headphones. Yet SETI keeps listening because the stakes are too high to quit. Projects like Breakthrough Listen now scan millions of stars with AI-powered analysis, hunting for patterns no human could spot. The Allen Telescope Array in California runs observations 24/7. It's dozens of dishes working in unison like a galactic ear trumpet. And then there's the mind-bending idea of technosignatures, not just radio waves but signs of alien megastructures like Dyson spheres harvesting a star's energy or industrial pollutants in an exoplanet's atmosphere. The irony, even if we found a signal tomorrow, confirmation could take generations. A message from a star 100 light-years away means we're hearing a transmission sent when our grandparents were kids. By the time we reply and they answer back, centuries might pass. First contact could be less like a conversation and more like sending letters across an ocean, with replies that outlive the people who started them. But that's the gamble SETI takes every day, because somewhere in the vast silence there might be another civilization pointing their own telescopes skyward, asking the same questions. And if they're listening, we'd better not miss the call. For decades, UFOs have been the stuff of late-night conspiracy shows and supermarket tabloids until suddenly they weren't. In 2020, the Pentagon dropped a bombshell, 3 declassified videos showing U.S. Navy pilots encountering objects defying known physics. One clip, nicknamed "Go Fast," captures a blur streaking over the ocean at impossible speeds. No wings, no exhaust plume, just raw, unsettling motion. Another, Gimbal, shows a tic-tac-shaped craft rotating midair like a bullet deciding to pirouette. These weren't shaky cell phone clips from a rural field. They were military-grade footage, filmed by trained observers with trillion-dollar tech at their fingertips. Then came the whistleblowers. In 2023, former intelligence officer David Grush sat before Congress alleging the U.S. government has been retrieving intact and occupied alien craft for decades. His claims, backed by other high-ranking officials, hinted at a shadowy reverse engineering program hidden behind layers of classified projects. Skeptics were quick to point out the lack of hard evidence, but the implications were staggering. If even a fraction of this is true, we're not just talking about unexplained lights in the sky, we're talking about artifacts, technology, maybe even beings. Science, of course, demands more than grainy videos and second-hand accounts. Physics professor Avi Loeb made headlines by dredging the Pacific Ocean for fragments of CNEO's 2014, an interstellar object that may or may not have been artificial. Meanwhile, NASA UAP study team stresses the need for rigorous data collection, calling out the stigma that's long discouraged pilots and scientists from reporting strange sightings. The truth is, most UAPs turn out to be drones, weather balloons, or optical illusions, but it's the handful that resist easy explanation that keep the debate alive. Pop culture hasn't helped. Hollywood's aliens are either wise mentors here to save us or slimy monsters hungry for conquest. Reality, if it's out there, is probably stranger. Imagine a civilization so advanced their technology seems like magic, or worse, so indifferent to us, we're just ants beneath their boots. The recent disclosures force an uncomfortable question. What if the mysteries in our skies aren't hallucinations or hoaxes, but something we're still not ready to face? The irony is thick. After centuries of wondering if we're alone, the universe might have been answering all along in ways we're only beginning to decode. Whether these phenomena are secret military tech, atmospheric oddities, or genuine extraterrestrial visitors, one thing's clear: the sky isn't just empty space anymore. It's a question mark, and it's watching us back. Imagine digging into the rusty soil of Mars, not for water or minerals, but for tiny fossilized bacteria. That's the quiet version of first contact. No flashing lights, no interstellar handshakes, just microscopic evidence that we're not the only ones who have called this universe home. Scientists call it shadow life organisms so alien they might not even use DNA. Finding them would rewrite biology textbooks, but it wouldn't spark panic in the streets. Instead, it'd fuel a deeper question. If life can ignite twice in one solar system, how unimaginably crowded is the cosmos? Now shift the scene. A radio telescope picks up a signal not static, not a quasar, but a deliberate mathematical sequence beamed straight at us. Think contact, not war of the worlds. Decoding it could take years, maybe centuries. Is it a greeting, a warning, or something we lack the context to even recognize, like trying to explain Wi-Fi to a medieval peasant? The message might not even be for us. Imagine tuning into a galactic podcast meant for civilizations a million years ahead of us, their language layered with concepts we can't grasp yet. Then there's the scenario that keeps diplomats awake, an actual ship parking itself over the White House. No warning, no hail, just silent, impossible tech hovering like a cosmic verdict. Would they be explorers, colonists, or something beyond our metaphors? Sci-fi loves extremes, the wise, gentle aliens of Arrival who speak in circular inkblots versus the city-zapping invaders of Independence Day. Reality, though, might be stranger. What if they're post-biological machines that outlived their creators, drifting for eons, or a hive mind that sees individuals the way we see skin cells? Here's the twist we've already rehearsed for this. The United Nations has an Office for Outer Space Affairs with protocols for first contact, and NASA sterilizes probes to avoid contaminating other worlds. But no manual can prepare us for the cultural quake of meeting intelligence that doesn't share our history, our instincts, or even our grasp of time. Picture trying to explain war to a species that's never known conflict, or art to beings who perceive dimensions we can't. The truth is, first contact won't fit a Hollywood template. It could be a quiet data drip or a thunderclap that shatters our place in the universe. The only guarantee, nothing will ever look the same again. In 1967, at the height of the Cold War space race, the United Nations drafted a document that would shape humanity's future in the cosmos, the Outer Space Treaty. Signed by over 100 countries, including the US and Soviet Union, it was less a rule book and more a gentleman's agreement scribbled on cosmic stationery. The treaty's big idea: space should belong to everyone, and no nation could claim the moon or planets as territory. Weapons of mass destruction were banned from orbit, and exploration had to benefit all humanity. On paper, it was noble. In practice, it's a relic straining under the weight of modern reality. The treaty's biggest flaw: it's toothless. There's no cosmic police force to punish violations, just diplomatic finger-wagging. When China landed a rover on the moon in 2013 and claimed exclusive mining rights near its landing site, the international community could only issue stern press releases. The treaty bans national appropriation, but it says nothing about corporations. Now, private companies like SpaceX and Blue Origin are eyeing lunar resources, and the legal gray zone is widening. Imagine a gold rush in orbit with no sheriff in sight. Then there's the language vague enough to drive a starship through. The treaty forbids harmful contamination of other worlds but doesn't define what that means. When NASA Perseverance rover drilled into Mars, some scientists winced. What if we're the invasive species? Conversely, the treaty demands we avoid adverse changes to extraterrestrial environments. But what if we find microbes on Europa? Does drilling through its ice sheet count as harm or science? The document mumbles where it should shout. Most glaringly, the Outer Space Treaty never imagined first contact. It regulates nations, not aliens. If an extraterrestrial ship landed tomorrow, there's no protocol for who greets them. Just a tangle of competing space agencies, militaries, and corporations all jostling for a seat at the table. The UN has a muted Office for Outer Space Affairs, but it lacks authority to enforce decisions. Picture the chaos if a mining company stumbled upon alien ruins and tried to monetize them before archaeologists could blink. Critics argue the treaty is frozen in a 1960s mindset where space was a two-player chess match between superpowers. Today, over 70 countries have space programs, and billionaires treat orbital launches like Uber rides. The rise of asteroid mining, space tourism, and potential off-world colonies has turned the treaty into a flickering candle against a hurricane. Some legal scholars push for a new framework, one with real penalties, clear environmental rules, and contingencies for discovering life. But getting global consensus now is like herding cats in zero gravity. The irony is thick. We drafted rules for space before we understood what space was. The Outer Space Treaty was meant to prevent conflict, but its gaps might invite it. As we stand on the brink of finding life or being found, we're stuck with a 50-year-old document that's less a roadmap and more a fading postcard from a simpler time. The stars deserve better. NASA takes planetary protection seriously, not to shield Earth from aliens, but to protect alien worlds from us. Think of it as an interplanetary version of a surgeon scrubbing in before an operation. Before any spacecraft touches down on Mars or swoops past Europa, it undergoes a rigorous decontamination process so aggressive it could make a bleach factory wince. The goal: prevent Earth microbes from hitchhiking to other worlds and messing up the search for extraterrestrial life, because finding a bacterium on Mars would be the discovery of the millennium, unless it's one we accidentally brought with us. The protocols are meticulous. For missions to places like Mars, where life might still cling to existence in subsurface brines, spacecraft are baked in giant ovens at temperatures high enough to kill even the hardiest extremophiles. Components that can't handle the heat, like sensitive electronics, get bathed in vaporized hydrogen peroxide, a sterilant so thorough it leaves no residue. The clean rooms where these probes are assembled look like something out of a sci-fi movie, with technicians shrouded in head-to-toe bunny suits to keep human skin cells from contaminating the hardware. But sterilization is just step one. When NASA Perseverance rover drilled into Martian rock, it didn't just scoop up samples, it sealed them in ultra-clean titanium tubes, future-proofing them for a potential return trip to Earth. Those tubes are like cosmic time capsules, designed to keep their contents pristine for decades until technology advances enough to study them without risk. And if scientists ever get their hands on brine from Europa's hidden ocean, the containment plan goes next level. Imagine a multi-layered, fail-secure lab with negative air pressure and robotic arms handling the samples behind inch-thick glass, a setup that makes a virology lab look lax. Astrobiologists are the gatekeepers here, balancing excitement with caution. They're the ones who'll decide if a strange molecule in Martian soil is proof of life or just geology playing tricks. But they're also the ones sounding alarms about back contamination, the nightmare scenario where a returning spacecraft brings home something that wasn't on the manifest. It's why samples from Mars won't land in a random field. They'll be quarantined in a facility with biosafety levels rivaling those used for Ebola. The irony is delicious. We spend billions searching for life beyond Earth, then bend over backwards to make sure we don't accidentally introduce it ourselves. But that's the paradox of exploration. To find the truly alien, we first have to confront how much of our own baggage we're carrying into the cosmos. By the 1990s, the idea of first contact had shifted from science fiction to something governments needed to prepare for, at least on paper. That's when the United Nations stepped in with a set of guidelines so cautiously optimistic they could have been drafted by a committee of diplomats and sci-fi fans. The Declaration of Principles concerning the use of outer space wasn't a law, wasn't a treaty, just a gentle nudge toward cosmic etiquette. It suggested that if we ever picked up an alien signal, the discoverers should, maybe tell someone. Preferably the scientific community, ideally the public, and absolutely not hoard the discovery like a classified military secret. the real muscle behind these ideas was COPUOS, the Committee on the Peaceful Uses of Outer Space. Founded during the Cold War, this UN body was supposed to keep space from becoming another battleground for superpowers, but when it came to first contact, COPUOS faced a problem. No one could agree on what to do. Scientists wanted open data sharing. Governments worried about panic, misinformation, or worse, giving strategic advantages to rivals. The result, a declaration full of shoulds and maybes with no teeth to enforce them. It's the difference between posting "please don't litter" signs in a park and actually fining someone for tossing a soda can. The glaring omission consequences. If a country or corporation detected a signal and sat on it, there'd be no sanctions, just awkward diplomatic scowls. Compare that to nuclear treaties where violations trigger real-world repercussions. The UN guidelines assume goodwill, but history shows that when stakes are high, goodwill often evaporates. Imagine a private company patenting an alien message as intellectual property, or a nation using first contact to flex geopolitical power. The 90s-era framework doesn't account for modern players like SpaceX or the rise of digital misinformation, where a single tweet about alien contact could crash markets before scientists verify the data. What's revealing is what the declaration doesn't say. There's no protocol for deciphering a message that might be hostile, no plan for cultural contamination if we reply with the wrong metaphor. Picture sending Shakespeare to a species that communicates in chemical signals. Our greatest poetry might read like a fridge manual, and while the UN urges international cooperation, it's silent on who gets to speak for Earth. Would we let the Security Council's permanent members draft a reply, or would scientists, artists, and philosophers get a seat at the table? The irony cuts deep. We have rules for protecting Antarctica's ecosystems and laws against littering on Mars, but the most momentous event in human history, proof we're not alone, has only a polite suggestion to coordinate. It's like planning for a hurricane by agreeing to share umbrella designs. As astrophysicist Jill Tarter once put it, we've built a haystack the size of the galaxy, and we're looking for a needle we're not even sure exists. But if we find it, we'll need more than a decades-old gentleman's agreement to handle what comes next. The truth is, humanity's plans for first contact are a patchwork of hope and bureaucracy, stitched together by committees that meet in windowless rooms. And while the UN's principles are a start, they're stuck in an era when dial-up internet felt fast and space was still a government monopoly. Today, the cosmos is busier and weirder than those drafters ever imagined. If a signal arrives tomorrow, we'll be scrambling to write the real rules on the fly. The moment a scientist spots something that might, just might, be proof of extraterrestrial life, the real work begins. Because in science, extraordinary claims don't just need evidence, they need to survive a gauntlet of skepticism so intense it makes a black hole look forgiving. Take the infamous Martian meteorite LH8401. In 1996, NASA researchers made headlines worldwide when they announced they'd found microscopic fossils in the rock, tiny shapes that looked eerily like fossilized bacteria. The press went wild. President Clinton addressed the nation. For a brief, shining moment, it seemed humanity had its answer. Then came the backlash. Other labs scrutinized the meteorite and the cracks started showing. Those fossils, they could have been formed by non-biological mineral processes. The organic compounds, possibly contamination from Antarctic ice where the meteorite sat for 13,000 years. Within months, the scientific consensus shifted from breakthrough to maybe not. ALH8401 became a cautionary tale, a reminder that in the hunt for alien life, hope can outpace proof. Today, the bar for confirmation is astronomically higher. If a Mars rover drills into a rock and detects strange molecules, the data won't just go to one lab. It'll be blasted out to researchers worldwide, from geochemists to microbiologists, each armed with their own tools and biases. peer review isn't just a formality here. It's a demolition derby where every assumption gets tested to destruction. Could those amino acids have formed without life? Are those weird carbon isotopes really a biosignature or just a quirk of planetary chemistry? The goal isn't to ruin the party, it's to make sure the party's built on bedrock, not sand. Independent replication is the gold standard. Imagine a team in Tokyo repeating an experiment with a Martian soil sample, while another in Berlin tweaks the parameters. If both get the same bizarre result, confidence grows, but even then, scientists will demand more. They'll simulate the conditions in a lab, trying to recreate the findings without invoking biology. They'll rule out contamination with forensic precision, tracking every fingerprint a human or machine might have left behind, and if the evidence still holds. Then, and only then, does the real conversation begin. This process isn't just slow by design, it's agonizing. In an age of viral misinformation, where a blurry photo can spark global conspiracy theories in minutes, science's deliberate pace feels glacial. But when the stakes are this high, when a single yes could redefine humanity's place in the universe, every maybe deserves its day in court, because the truth isn't just out there. It's waiting for us to prove we're ready to see it. Picture this: a scientist in a radio telescope control room stares at a screen, her hands shaking as the data scrolls by. The signal is real, it's artificial, and it's definitely not human. Her first instinct: call the world, but then reality crashes in. Who actually gets to announce that humanity isn't alone? The researchers who found it, the president of their country, the United Nations. This isn't just about protocol, it's about power, trust, and the fragile balance between truth and chaos. History offers a grim warning. In 1938, Orson Welles' War of the Worlds radio drama, presented as a series of fake news bulletins, sparked mass panic. Listeners fled cities, clogged highways, and even swore they smelled alien poison gas, all from a fictional broadcast. Now imagine that reaction multiplied by social media's wildfire speed. A leaked snippet of an alien signal, misunderstood and stripped of context, could trigger stock market crashes, riots, or worse before the facts even surface. Scientists argue disclosure should follow the SETI post-detection protocol, a voluntary roadmap where discoverers verify the signal, alert global colleagues, and only then inform the public through coordinated channels. But here's the catch: science moves at the speed of peer review, while Twitter moves at the speed of speculation. In 2017, when astronomers detected Oumuamua, the first known interstellar object, wild theories about alien probes overshadowed the data. Now scale that to an actual message. Without airtight controls, someone will hit send prematurely, whether for fame, ideology, or just a hacked server. Governments, meanwhile, see first contact as a national security issue. Imagine China detecting a signal and delaying disclosure to strategize, or a U.S. administration weaponizing the news cycle. Classified briefings could lock out scientists, leaving the world's understanding filtered through political spin. And let's not forget corporations. What if a private space company like SpaceX or Blue Origin controls the discovery? Their shareholders might demand monetization, turning history's greatest revelation into a paywalled livestream. The UN's Office for Outer Space Affairs insists they should steward the message, framing it as a collective human moment, but their slow-moving bureaucracy could stumble in a crisis. Remember how COVID-19 information fragmented across borders. Now replace virus strains with alien math. The risk isn't just panic, it's versioning, competing narratives fracturing global response. Perhaps the solution lies in redundancy. A network of pre-authorized figures, Nobel laureates, trusted journalists, cultural leaders ready to translate the discovery simultaneously in every language. Not as a press release, but as a shared story, because the truth won't just change what we know, it'll change who we think we are, and that's not an announcement. It's a conversation the whole planet needs to have. The moment humanity confirms we're not alone, the foundations of society won't just shake, they might fracture. History shows we don't handle paradigm shifts gracefully. When Copernicus suggested Earth wasn't the center of the universe, it took a century for the Church to stop calling heresy. Darwin's theory of evolution still sparks courtroom battles 200 years later. Now imagine a revelation thousands of times more disruptive landing in our social media feeds overnight. The Brookings Institution warned about this exact scenario back in 1961. Their report to NASA wasn't about rocket science, it was about human psychology. They predicted that contact with superior extraterrestrial intelligence could trigger cultural collapse, especially in societies where belief systems hinge on humanity's special place in creation. Some religions might adapt, folding aliens into divine plans. Others could face existential crises when ancient texts say nothing about silicon-based lifeforms orbiting Vega. But it's not just about theology. Our entire social hierarchy would get scrambled. How do class divisions matter when another species makes our smartest minds look like toddlers? National borders might seem laughably small under a galactic lens, yet paradoxically, some governments could clamp down harder, fearing loss of control. Studies on mass psychology show that when faced with overwhelming unknowns, populations often split between those craving unity and those retreating into tribal suspicion. The optimists see first contact as the ultimate unifying force, a cosmic kickstart to global cooperation. Picture climate summits where nations finally work together, not for economic gain, but to present Earth as a mature civilization worthy of interstellar respect. Scientists fantasize about shared knowledge vaults where humanity contributes everything from Beethoven's symphonies to quantum equations, joining a galactic library of civilizations. Then there's the darker scenario. The same Brookings report noted that throughout history, encounters between advanced and less advanced civilizations rarely ended well for the latter. Even without hostile intent, cultural contamination could erode human institutions faster than we could adapt. Economies might crash overnight if alien tech renders entire industries obsolete. Conspiracy theories would explode. Are governments hiding the truth? Have aliens already infiltrated? The same internet that spreads cat videos could become an epidemic of paranoia. Psychologists point to our track record with lesser disruptions. When radio broadcasts began crossing borders in the 1920s, some nations banned receivers, fearing foreign ideas. The mere possibility of alien microbes sent NASA scrambling with quarantine protocols. Now amplify that anxiety by a million. What happens when people realize we're no longer the apex intelligence in the known universe? Some might welcome our cosmic neighbors with open arms, others would build bunkers. The defining factor may be time. A sudden, undeniable event like a ship appearing over New York would shock systems to the breaking point. But a slow discovery, like decades decoding a radio signal, could let humanity adjust gradually. The irony, we've spent so much effort searching for extraterrestrial life, we've barely prepared for the one thing guaranteed to happen if we find it ourselves. History has a cruel habit of repeating itself, especially when power is at stake. The moment alien technology enters the equation, every nation with a space program will face an impossible choice: collaborate or conquer. Remember the scramble for Antarctica in the 20th century? That territorial frenzy would look tame compared to the gold rush for a crashed extraterrestrial probe or a decoded alien transmission. Whoever controls first contact doesn't just gain prestige, they could leapfrog centuries ahead in physics, energy, or weaponry overnight. China's already staking claims on the moon. The US Space Force trains for orbital combat. Russia revives Soviet-era anti-satellite projects. These aren't coincidences. Their chess moves in a game where the ultimate prize might not be land or oil, but knowledge from a civilization that cracked interstellar travel. Imagine the tension if a U.S. rover stumbled upon alien artifacts in a crater only for a rival nation to land nearby, citing scientific cooperation while quietly deploying extraction drones. The Outer Space Treaty bans weapons in orbit, but it says nothing about securing alien tech with armed satellites. Legal gray zones have a way of turning into conflict zones. The darkest scenario, a new Cold War fought over cosmic secrets. During the original space race, the US and USSR at least agreed not to nuke each other's satellites. But what happens when the stakes include, say, a device that manipulates gravity or a message containing blueprints for limitless energy? Intelligence agencies would infiltrate research labs. Hackers would target astrophysicists' hard drives. Nations might hoard discoveries like nuclear codes, fearing that sharing even a fragment could hand adversaries an unbeatable edge. The irony is bitter. First contact could unite humanity, or it could splinter us into factions racing to weaponize the unknown. Space militarization is already creeping forward. India's tested anti-satellite missiles. France boasts space defense squadrons. The Pentagon's budget includes exotic aerospace threat programs. These initiatives aren't about aliens yet. But the infrastructure being built today could easily pivot toward intercepting alien messages or seizing extraterrestrial debris. Picture a future where spacecraft don't just carry telescopes, but EMP cannons for protection, of course. Diplomacy isn't ready for this. The UN's Outer Space Committees move at bureaucratic speed, while private corporations like SpaceX operate on Silicon Valley time. If Elon Musk's Starship recovers alien material before governments even draft a response plan, who gets custody? The scientific community, the Pentagon. A boardroom in California, precedent isn't reassuring. When U.S. museums hold looted artifacts, repatriation takes decades. Now scale that to relics that might rewrite the laws of physics. The brutal truth, humanity's greatest discovery could become its most volatile bargaining chip. Nations that can't agree on climate treaties or trade deals will suddenly face stakes that dwarf both. The same instincts that drove colonization and arms races won't vanish just because the prize came from the stars. If history's any guide, we'll see alliances fracture, spy networks bloom, and black budgets balloon, all before we even understand what we're fighting over. The moment alien technology or intelligence enters our reality, global markets won't just fluctuate, they'll undergo a seismic recalibration. Think of the Industrial Revolution, but compressed into weeks instead of decades. Some industries would skyrocket overnight, while others crumble into obsolescence. At the top of the boom list, space infrastructure. Suddenly, every billionaire's vanity rocket project becomes a strategic necessity. Companies like SpaceX and Blue Origin would pivot from lunar tourism to interstellar logistics, racing to build docking stations, refueling depots, and translation hubs for potential alien visitors. The demand for engineers fluent in xenotech, a field that doesn't even exist yet, could make software engineers during the dot-com bubble look underpaid. Then there's asteroid mining, an industry currently stuck in PowerPoint presentations. The discovery of advanced extraterrestrial civilizations could unlock metallurgy secrets that make extracting rare metals from asteroids as routine as drilling for oil. Imagine platinum group metals harvested not in grams, but in megatons, crashing the value of Earth-bound mining overnight while birthing trillion-dollar orbital refineries. Energy would face its own revolution. If alien tech hints at zero-point energy or compact fusion, fossil fuel empires could collapse faster than coal towns in the 1950s. Saudi Arabia's oil fields might become relics, while patents for reverse-engineered alien power cells spark legal wars fiercer than any smartphone patent battle. But the upheaval wouldn't stop at hardware. Linguistics AI would explode as governments and corporations scramble to decode alien syntax. Today's large language models parse human languages tomorrow's might need to interpret chemical swarms or quantum-entangled symbols. The Rosetta Stone of first contact won't be a rock, it'll be a server farm running algorithms we can't yet fathom. Meanwhile, telecom companies would lobby for exclusive rights to beam replies into space, turning deep space bandwidth into a commodity traded like oil futures. The casualties, organized religion might face the sharpest existential reckoning. Faiths built around humanity's divine uniqueness would need to reconcile with a cosmos teeming with other sentient beings, some possibly millions of years older. Mega churches could empty while new hybrid cosmologies emerge, blending scripture with astrobiology. The travel industry would also pivot violently. Why visit Paris when you could theoretically book a guided tour of a Dyson sphere? Entire sectors like fossil fuels, traditional manufacturing, and even pharmaceuticals could unravel if alien knowledge offers cleaner, smarter alternatives. Yet for every industry that collapses, a dozen niche markets would rise from the chaos. Ethical consultancies for interspecies trade, alien tech liability insurance. Even entertainment would rebrand Hollywood's first contact blockbusters replaced by documentaries starring actual extraterrestrials, the real wild card. Black markets, governments might classify alien tech as a matter of national security, but that won't stop smugglers from peddling fragments of wreckage or bootlegged alien code on the dark web. Economists warn that such rapid disruption could make the crypto crash look orderly. Stock markets might freeze under the weight of too many unknowns. Central banks would grapple with currency stability if asteroid mine platinum floods the market. Universal basic income debates would reignite as entire workforces become obsolete overnight. But history offers a glimmer of hope. Every major technological leap, from steam engines to the internet, eventually created more jobs than it destroyed. The difference this time, we wouldn't be racing against machines we built. We'd be scrambling to keep up with knowledge dropped into our laps from civilizations that see our smartest innovations as cave paintings. The bitter irony, humanity's economic systems are built on scarcity, but the cosmos might operate on abundance. A single alien energy recipe could end hunger, climate change, and wars over resources, or it could widen inequality into a chasm if controlled by a handful of elites. The real test won't be technological. It'll be whether we can reinvent capitalism itself before the stars force our hand. Imagine a team of scientists standing over a chunk of metal that defies every textbook in the room, its surface flawless, its structure lighter than aluminum but stronger than titanium, humming faintly with energy we can't measure. This isn't sci-fi, it's the first day of humanity's greatest homework assignment, reverse engineering technology built by minds that might not even think in terms of machines as we understand them. The challenge wouldn't be like taking apart a smartphone to see how it works. It'd be more like a medieval blacksmith handed a nuclear reactor and told to figure it out with a hammer and chisel. Start with the basics: material science. Alien alloys might be forged in conditions we can't replicate, like the heart of a neutron star or a lab manipulating quantum states we haven't discovered. Take the hypothetical unobtainium, a material sci-fi writers joke about because it's impossible on Earth. Real-world scientists face this already. Nitinol, a shape memory alloy developed in the 1960s, bends and snaps back to form with heat, a parlor trick compared to what extraterrestrial metallurgy might do. Now picture a substance that rearranges its atomic structure on command or harvests energy from dark matter. Our microscopes might not even recognize the building blocks. Then there's the power source. Human tech runs on combustion, fission, or batteries' clunky methods next to a device that taps into zero-point energy or harnesses the spin of electrons in ways that make our quantum computers look like abacuses. The closest parallel, the Antikythera mechanism, an ancient Greek computer found in a shipwreck. For decades, archaeologists assumed it was debris until X-rays revealed gears predicting planetary movements. It took a century to grasp its purpose because the creator's knowledge was lost. Now scale that gap to technology potentially millions of years ahead of us. The real nightmare: interfaces. Alien tech might not have buttons, screens, or even physical controls. What if it operates via thought waves, biological symbiosis, or dimensions we can't perceive? Imagine staring at a console that's just a smooth orb reacting to no stimulus we can provide. History's littered with examples of cultures misinterpreting advanced artifacts. When the Spanish arrived in the Americas, Aztec scholars reportedly smashed European clocks, believing them alive because they moved on their own. Now flip the script. Would we accidentally activate a doomsday protocol while poking at what we think is an alien coffee maker? Breakthroughs wouldn't come from lone geniuses but global coalitions. The Manhattan Project marshaled the world's top physicists. Decoding alien tech would require a planetary dream team: materials scientists, linguists, even philosophers probing how another species conceptualizes reality. Labs would need tools rebuilt from scratch, like particle accelerators the size of cities, or AI that evolves alongside the tech it studies. And secrecy. Impossible. Unlike classified military projects, this knowledge would be too explosive and too lucrative to contain. Every corporation, government, and hacker collective would race to crack even a single equation. Yet for all the chaos, reverse engineering alien technology could force humanity's greatest collaborative leap. The Industrial Revolution took centuries. This would compress progress into years. Medical tech might cure diseases by rewriting cellular code. Transportation could abandon fossil fuels for systems bending spacetime. But the cost, our entire understanding of physics, maybe even reality, would shatter. We'd face truths as unsettling as they are exhilarating, that we're not the pinnacle of intelligence, just another species fumbling in the cosmic dark, handed a lantern we don't yet know how to light. Now let's tackle perhaps the most daunting hurdle of first contact: language. Imagine receiving a message from an alien civilization that doesn't share our concept of words, sounds, or even linear time. Their speech might be color pulses, magnetic waves, or fractal patterns our brains aren't wired to process. This isn't just about vocabulary, it's about decoding an entirely alien way of thinking. Back in 1960, mathematician Hans Freudenthal designed Linko's, short for Lingua Cosmica, a constructed language built on universal concepts like math and logic. The idea was elegant: start with simple numerical sequences, 1 + 1 = 2, then build up to complex ideas using symbolic logic any intelligence could grasp. But Linko's hit a wall. Human languages rely on shared context. What if aliens don't experience left or right in 3 dimensions? What if their biology has no concept of hunger or pain? Enter AI. Modern machine learning offers tools Linko's creators couldn't dream of. Neural networks trained on thousands of human languages can now detect patterns invisible to us, like how the heptapods in Arrival communicated in circular ink blots that embodied their non-linear perception of time. In reality, researchers are developing algorithms that don't just translate words but infer meaning structures. An alien message might not use nouns and verbs. It could layer information like a quantum superposition, where every symbol contains multiple states at once. But here's the catch: AI needs data to learn. Without a Rosetta Stone, some shared reference point, even the smartest algorithm is guessing. That's why some scientists propose active learning dialogues, sending simple probes like geometric shapes paired with reactions: flash, circle, get a response. Over millennia, a conversation might emerge. Others suggest exploiting universal physics. Hydrogen atoms emit radio waves at a specific frequency. Use that as a numeric foundation, then build outward. The terrifying beauty: we might not even recognize their language as language. The Arecibo Message depicted humans as stick figures. What if aliens encode information in quantum spin states or gravitational waves? Our best hope: stay humble. the universe isn't obliged to speak in ways we understand. Decoding first contact won't be like cracking Egyptian hieroglyphs with the Rosetta Stone. It'll be more like teaching a blindfolded person to describe fireworks using only the sound of rain. The moment an alien microbe hitches a ride to Earth, whether on a returning spacecraft or inside a meteorite fragment, humanity faces a biological gamble unlike anything in our history. Think of the Andromeda strain scenario, but with higher stakes. A pathogen evolved in an alien biosphere, following biochemical rules we've never encountered. Our immune systems wouldn't just be unprepared, they might not even recognize the threat as alive. Unlike earthly viruses that rely on DNA or RNA, extraterrestrial microbes could store genetic information in exotic polymers, molecules that slip past our defenses like ghosts through walls. Planetary protection protocols are our first line of defense. NASA cleanrooms and sample return quarantine facilities are designed to contain unknown biological hazards with the rigor of a maximum security biolab. The European Space Agency's proposed Mars Sample Receiving Facility takes this further, featuring multiple airlocks, robotic handling systems, and sterilization chambers that could incinerate rogue microbes at 2,000 degrees Fahrenheit. But containment is only half the battle. If an alien pathogen breached these safeguards, traditional antibiotics and antivirals would be useless against biochemistry built from different molecular scaffolding. This is where CRISPR and synthetic biology enter the equation. Scientists are already experimenting with gene drives that could rapidly engineer human immune cells to recognize and attack non-terrestrial threats. Picture a library of xenogenic CRISPR templates, pre-loaded genetic blueprints designed to target hypothetical alien biomolecules, from silicon-based enzymes to arsenic-laced proteins. The catch: we'd need samples of the alien microbes to tailor these defenses, which means risking exposure to study the very thing we're trying to defeat. History offers sobering parallels. When European settlers brought smallpox to the Americas, indigenous populations faced mortality rates exceeding 90% because their immune systems had no evolutionary exposure to the virus. Now reverse the scenario. What if, with the Native Americans confronting an interstellar variola, the solution might lie in synthetic biology's most radical frontier, creating universal immune sentinels? Researchers at MIT have prototyped nanoparticles that bind to any pathogen by targeting physical traits like surface charge rather than specific molecules. Deployable as a nasal spray, such broad-spectrum defenders could buy time while CRISPR therapies are customized. The darkest twist: some astrobiologists argue the greatest risk isn't hostile aliens, it's indifferent ones. A microbe evolved to thrive in Martian brine might colonize human tissue accidentally, not out of malice but simply because our bodies offer saltwater and warmth. Like the invasive species that overrun ecosystems when transplanted to new continents, extraterrestrial life could disrupt Earth's biosphere through sheer incompatibility. Our best hope lies in layering defenses, physical containment, rapid genetic countermeasures, and perhaps even synthetic organisms designed to outcompete alien microbes in our own bodies. The irony cuts deep. We spend billions searching for life beyond Earth, only to realize the most dangerous discovery might not be a spaceship or a radio signal, but a single droplet of liquid carrying something we can't see, don't understand, and aren't ready to fight. In the cosmic game of immune systems, humanity is gambling that we can learn the rules before the clock runs out. Finding alien microbes under a Martian rock would force humanity to confront an ethical dilemma we've never faced. What do we owe life that isn't ours? On one side, scientists argue these organisms deserve protection as the first known examples of life beyond Earth, unique products of cosmic evolution that could help us understand our own origins. The other side sees opportunity. Extremophiles from Europa's oceans might hold biotech breakthroughs, from radical new enzymes to cancer-killing compounds. It's the tension between reverence and utility playing out on an interplanetary scale. History offers sobering parallels. When European explorers encountered the dodo bird, they saw dinner, not a marvel of island evolution, and drove it extinct within decades. The Antarctic Treaty now protects that frozen continent as a scientific preserve, but only after whalers and miners nearly stripped it bare. These examples show how easily exploitation wins when discovery meets ambition. The Outer Space Treaty vaguely mandates preventing harmful contamination, but it's silent on whether drilling into Martian bacteria for profit counts as harm. For intelligent aliens, the stakes skyrocket. How would we prove another species is truly sentient? Dolphins recognize themselves in mirrors. Octopuses solve complex puzzles. But we still farm them. Scientists propose cosmic versions of the Turing test, observing whether aliens demonstrate creativity, self-awareness, or moral reasoning. The challenge: our tests might be as meaningless to them as a Rorschach inkblot is to a supercomputer. Legal scholars whisper about interstellar human rights, but the frameworks are thin. The Declaration of the Rights of Man took centuries to evolve into modern laws, time we wouldn't have if a starship arrived tomorrow. Some suggest adapting the UN's indigenous rights protocols, treating alien civilizations as sovereign entities with rights to their knowledge and territory. Others warn this risks noble savage romanticism, projecting human ideals onto minds that might value entirely different things. The darkest question: whether advanced aliens would extend us the same ethical consideration. If we discovered a planet full of intelligent but less technologically developed beings, would we observe or interfere? The prime directive from Star Trek sounds noble until you realize it's a policy of non-help, letting civilizations suffer plagues and wars to develop naturally. Our track record with Earth's own species suggests we shouldn't assume the moral high ground just yet. Perhaps the answer lies in humility, until we truly understand alien perspectives, if such understanding is even possible. The safest path is treating all extraterrestrial life as inherently valuable rather than commercially exploitable. Because once we cross that line, there's no going back. The universe might remember our choices long after our civilization is dust. The discovery of intelligent alien life wouldn't just shake laboratories, it would rattle stained glass windows. For centuries, Earth's dominant religions have built cosmic narratives around humanity's divine uniqueness. What happens when that narrative collides with proof we're not alone? The Vatican's own astronomers have already weighed in. At the Pontifical Academy of Sciences, Jesuit brother Guy Consolmagno, nicknamed the Pope's astronomer, publicly stated that he'd baptize a willing extraterrestrial, echoing his predecessor's famous quip that aliens are God's creatures too. This isn't just progressive theology, it's strategic adaptation. Catholicism's long history of absorbing scientific shocks, from Galileo's telescope to Darwin's fossils, suggests it might reframe first contact as proof of God's boundless creativity rather than a threat to doctrine. But not all faiths would pivot so smoothly. In 2018, Saudi Islamic scholars issued a fatwa warning Muslims against praying toward Mecca if stationed on Mars, revealing how extraterrestrial realities could fracture earthly rituals. Meanwhile, evangelical Christianity's literal interpretation of Scripture faces sharper tension. If Adam's sin brought death to Earth, does that mean aliens have their own Adam? Or did Christ's sacrifice cover the entire cosmos? Prominent pastors like the late Billy Graham waffled, calling aliens possible, while insisting salvation lies solely in Jesus. The friction here is tectonic. Evangelicalism's insistence on humanity's central role in God's plan clashes with a universe teeming with other sentient beings. Then there's the Raelian movement, a UFO religion that turns traditional theology upside down. Founded by French race car driver Claude Vorilhon, who claimed extraterrestrials named Elohim created humans through genetic engineering, the group actively campaigns for interstellar diplomacy. Their temples resemble sci-fi lounges, complete with swirling galaxy motifs and a logo featuring a Star of David entwined with a swastika, a controversial nod to the Elohim's alleged symbols. While mainstream science dismisses Raelians as a cult, their explosive growth, over 90,000 members worldwide, hints at the spiritual vacuum first contact might ignite. Buddhism and Hinduism, with their cyclical cosmologies and multiverse concepts, might adapt most gracefully. The Dalai Lama has mused that aliens likely exist and may be more spiritually advanced than humans, aligning with Buddhism's infinite realms of existence. Hindu texts like the Puranas describe flying vimanas and battles between celestial beings, ancient lore some reinterpret as evidence of past extraterrestrial contact. These traditions' fluid boundaries between science and mythology could make them shock-absorbent when reality outpaces scripture. The real crisis might hit fundamentalist sects across all religions that stake their authority on rigid textual interpretations. Imagine creationists confronting a civilization with fossil records older than Genesis 6,000 years, or Muslim scholars debating whether silicon-based lifeforms require halal diets. Theologians are already gaming out responses, from expanding the concept of chosen people to galactic scales to speculating about multiple incarnations of Christ-like figures across star systems. Yet history offers a curious precedent. When European explorers encountered indigenous Americans, Catholic authorities convened the Valladolid debate in 1550 to determine whether natives had souls. The outcome, a shaky, yes, reshaped colonialism's moral landscape. A modern Valladolid moment could force religions to decide, do aliens have souls, and if so, have they heard the gospel, or are they preaching something we've never imagined? The pews are waiting. Carl Sagan once described Earth as a pale blue dot, a fragile speck suspended in a sunbeam, an image that humbles borders and ideologies into irrelevance. That same perspective could shape humanity's greatest interstellar handshake, deciding what parts of ourselves we share with the cosmos and what we keep guarded. Imagine composing a cultural care package for alien civilizations. Mathematics would be our universal opener, prime numbers, geometric proofs, the Fibonacci sequence etched into radio waves. These concepts transcend language, a cosmic lingua franca any technologically advanced species would recognize. But after equations comes the soul stuff: Bach's fugues, Van Gogh's Starry Nights, Maya Angelou's poetry. Art doesn't just showcase skill, it reveals what terrifies, delights, and mystifies us. A single Beethoven symphony conveys more about human emotion than an encyclopedia ever could. Yet restraint matters as much as generosity. Sharing every breakthrough risks handing over tools we barely control ourselves. Nuclear physics sits at the top of the caution list, not just weapons, but the raw knowledge to manipulate atomic bonds. History shows how quickly theoretical papers become mushroom clouds. Even seemingly benign tech like artificial intelligence carries existential risks if repurposed by minds with alien values. The Voyager golden record played it safe, omitting schematics for rockets or antibiotics. Its curated snapshots laughing children, Olympic sprinters, a chimpanzee using tools presented humanity at its most aspirational, not its most destructive. This tension between openness and caution reflects Earth's own struggles. When Western explorers shared gunpowder with 15th century Japan, it revolutionized warfare there within decades. Cultural exchange cut both swords, but Sagan argued that space exploration demands maturity, the recognition that in the cosmic dark, we're all crewmates on the same fragile vessel. His pale blue dot vision wasn't just poetry, it was a manifesto for planetary unity. To alien civilizations, we wouldn't be Americans, Russians, or Congolese, we'd be Earthlings. The irony, the very act of selecting what to share forces introspection. Including Shakespeare but omitting Das Kapital reveals biases, showcasing the International Space Station but skipping Slum's airbrushes reality. Perhaps the most honest message would be unvarnished: our triumphs and our wars, our climate solutions and our oil spills. Let the universe see us whole, not as angels or demons, but as a species stumbling toward wisdom. Because first contact won't just introduce aliens to humanity. It'll hold up a mirror showing us who we truly are when the stars start watching back. Stephen Hawking once compared contacting advanced alien civilizations to Columbus landing in the Americas. It didn't turn out well for the Native Americans. His chilling warning wasn't just pessimism, it was grounded in evolutionary biology. Across Earth's history, encounters between unequal technological societies rarely end peacefully. Now imagine that imbalance scaled to interstellar proportions. A civilization capable of crossing light years wouldn't just outgun us, they'd operate on timescales and with technologies we can't fathom. Their weapons might not even look like weapons. A swarm of self-replicating nanobots could dismantle our infrastructure molecule by molecule. A modified black hole the size of a tennis ball could swallow Earth whole. Or worse, they might not intend harm at all, viewing us the way we view ants beneath a highway construction site. Humanity's current defense plans swing between Hollywood fantasy and sober realism. The Pentagon's 2023 report on unidentified aerial phenomena included classified annexes about potential threat assessments, while NASA's Planetary Defense Office focuses on asteroid deflection skills that might translate to intercepting alien probes. Some theoretical counters sound ripped from sci-fi. Space-based laser arrays like the ones China's testing for satellite defense, electromagnetic railguns that could launch projectiles at relativistic speeds, or even AI-piloted drone swarms designed to overwhelm hostile craft. But here's the brutal truth: if an advanced civilization wants Earth, no amount of human ingenuity would stop them. Our nukes would be as threatening to their starships as spears are to tanks. Diplomacy might be our only viable shield. Experts like SETI Douglas Vakoch argue that preemptive de-escalation should be baked into any interstellar messaging. Instead of broadcasting our military prowess or resource locations, essentially painting a target on our planet, we could signal peaceful intent through universal mathematical harmonies or art. The logic's counterintuitive but sound. A species capable of empathy for abstract beauty might be less likely to exterminate. History offers slivers of hope. During the Cold War, Soviet and American scientists secretly collaborated on protocols for joint alien contact, proving even rivals can unite against existential unknowns. Yet Hawking's ghost lingers over every optimistic scenario. Evolution favors survival traits, not morality. A civilization that conquered interstellar travel might have outcompeted countless rivals, hardening into something ruthlessly pragmatic. Their concept of diplomacy could involve experiments we'd call atrocities, studying us like lab rats or strip mining our planet for exotic matter. Some astrobiologists suggest the Great Silence itself is evidence of such predators, that advanced species learn to hide rather than attract attention. The darkest paradox: our best defense might be obscurity. Right now, Earth leaks radio waves and light pollution like a beacon. Over a century of TV broadcasts have already reached thousands of stars. But as fiber optics replace broadcast towers and civilizations transition to quieter communication, we might fade from the cosmic radar. Future generations could deliberate going dark, choosing silence over the gamble of shouting into an unknown jungle. Because in the end, the universe doesn't care about fairness. It only rewards those who survive. Picture a future where humanity isn't just knocking on the cosmos's door, we're handed the keys. The moment an advanced civilization shares even a fraction of their knowledge, the domino effect could catapult us into a golden age. Take energy first. Fusion reactors here on Earth still guzzle more power than they produce, but imagine alien tech handing us the blueprint for a reactor no bigger than a car engine, fueled by seawater and emitting zero radiation. Cities could run on pocket-sized power plants, ending oil wars and smog-filled skies in a generation. Solar panels might tap into wavelengths of light we can't even see, turning every rooftop into a powerhouse. The catch: this isn't just about free energy, it's about redefining scarcity itself. Now stretch that ripple to medicine. Alien biochemistry could unravel cancer like a simple math problem, introducing nanobots programmed to rewrite diseased cells at the atomic level. Aging might become optional, telomeres repaired, synapses rewired, organs regrown on demand. Epidemics would vanish overnight with vaccines tailored in hours, not years. But the real revolution: neural interfaces translating alien brain scans into therapies for depression, PTSD, even consciousness expansion. Suddenly, mental health isn't about coping, it's about transcending. Space exploration shifts from lonely probes to cosmic carpools. Shared propulsion tech could slash Mars travel time from months to days, with gravity manipulation making spacecraft feel like luxury hotels instead of claustrophobic tin cans. Jupiter's moons become pit stops, not pipe dreams, as we co-build research stations with species who have already mapped the galaxy. Picture a Martian library where human and alien scientists swap day to not in papers, but through direct neural feeds. Einstein meets Spock in a mind meld of breakthroughs. Even Earth's ugliest problems crumble under interstellar collaboration. Climate engineering moves from desperate geohacks to elegant atmospheric reprogramming, with alien atmospheric models predicting storms centuries in advance. Plastic pollution: engineered microbes digest it into harmless, even useful byproducts. The catch is cultural humanity would need to shed its tribal instincts faster than ever before. But when the alternative is thriving among the stars, pettiness might just seem as archaic as bloodletting. The most profound gift might be perspective. Learning we're not the universe's apex intelligence could humble our egos while expanding our ambitions. Art, music, and philosophy would explode with new form sculptures in 4 dimensions, symphonies composed for senses we don't yet possess. Religions might merge into cosmic spiritualism, finding common ground in awe rather than dogma. The best-case scenario isn't just about gadgets or longevity. It's about evolving into something wiser, kinder, and finally ready to call the cosmos home. Right now, humanity is like a student cramming for a final exam we didn't know we had, because one day, the universe might call on us to prove we're ready for the cosmic stage. Think about it: we drill for earthquakes, hurricanes, even zombie apocalypses. But first contact, that's the ultimate pop quiz, and we haven't even sharpened our pencils. The solution isn't just bigger telescopes or faster rockets. It's rewiring how we think, learn, and cooperate on a planetary scale. Start with education. Today's kids memorize periodic tables and quadratic equations. But what about decoding alien math or negotiating with non-carbon-based intelligences? Schools should weave astrobiology into biology classes, xenolinguistics into language arts, and interstellar ethics into civics. Imagine high school debates where students role-play galactic envoys, arguing whether to share Earth's location or keep quiet. Finland's already pioneering this. Their latest curriculum includes future skills modules on space diplomacy and crisis communication. These aren't sci-fi electives, they're survival tools for a generation that might actually face these questions. Then there's the knowledge gap. NASA and ESA scientists might grasp orbital mechanics, but what about small-town mayors or rural doctors? First contact won't just happen in labs. It'll ripple through grocery stores, stock markets, and places of worship. That's why we need global space literacy initiatives, crash courses on radio astronomy, exobiology, and cosmic risk assessment, taught through community centers and streaming platforms. During the pandemic, we saw how quickly misinformation spreads when people lack scientific context. Now magnify that by a billion. A single misunderstood alien signal could trigger panics we can't undo. But education alone isn't enough. We need institutions with teeth. The United Nations Office for Outer Space Affairs is a start, but it's underfunded and politically hamstrung. Picture something bolder: a planetary space agency, modeled on climate accords but with real authority. A unified body pooling resources from every nation, where astrophysicists, diplomats, and AI ethicists draft enforceable protocols for first contact. No more rogue billionaires beaming memes into space or countries hoarding alien artifacts. One Earth, one voice, or at least something close. Mock drills could pressure test these systems. The US and USSR once rehearsed nuclear war with eerie realism. Why not simulate an alien megastructure spotted near Saturn? In 2022, the International Academy of Astronautics ran a tabletop exercise where teams responded to an extraterrestrial signal. The chaos was revealing. Scientists clashed with military advisors, while PR teams fretted over phrasing like intelligent origin versus non-human technology. These dry runs expose flaws no theory can predict. Public awareness is the final pillar. Forget clandestine government meetings. First contact belongs to everyone. Documentaries like Contact and Arrival get one thing right. The moment we know we're not alone, streets will fill not with riots, but with people staring skyward, united by awe. But awe without preparation breeds conspiracy. Agencies should declassify more UAP data, not to fuel paranoia, but to normalize the idea that the cosmos is stranger than we imagine. Museums could host alien culture exhibits exploring how life might evolve in methane seas or binary star systems. The goal: make the unknown feel less threatening, because fear fades when wonder takes its place. The hard truth: we're not ready. Our schools teach competition over cosmic citizenship. Our leaders can't agree on climate treaties, let alone interstellar ones. But the stakes are too high to fail. Whether first contact comes in 50 years or 5 centuries, the work starts today. Not with panic, but with pencils down and hands raised, eager to answer when the universe finally calls roll. Right now, humanity's first contact protocols aren't just outdated, they're dangerously naive. The United Nations Guidelines for Extraterrestrial Communication read like a well-meaning but toothless school project, full of shoulds and maybes with zero enforcement. Picture a fire drill where the instructions are scribbled in crayon and the exits are locked. That's essentially our planetary blueprint for greeting intelligent life. The current framework, drafted in the 1990s, assumes goodwill and transparency from every nation, a lovely thought, but one that crumbles the moment you remember how governments hoard power. When China's 500-meter aperture spherical telescope picks up an alien signal tomorrow, what stops them from classifying it as a state secret? What prevents SpaceX from monetizing a reply? The truth is, our cosmic welcome mat is a patchwork of hopeful suggestions, not laws. We need binding treaties, not polite handshakes. The Outer Space Treaty of 1967 was revolutionary for its time, banning nukes in orbit and declaring space a shared commons. But it's a relic of the Cold War, silent on AI, megacorporations, and the scramble for alien tech. A modern interstellar accord would need sharp teeth, mandatory disclosure timelines, whistleblower protections for scientists, and harsh sanctions for any nation or corporation that tries to weaponize first contact. Think of the Montreal Protocol that saved the ozone layer, but for galactic diplomacy. The United Nations Office for Outer Space Affairs should be overhauled into a planetary contact authority with real funding and subpoena power, because right now it's understaffed and overshadowed by national space agencies elbowing for advantage. But top-down solutions aren't enough. Enter the grassroots pioneers quietly rewriting the playbook. METI, International Messaging Extraterrestrial Intelligence, operates on a shoestring budget, yet they've drafted the most detailed protocols for interstellar dialogue ever conceived. Their scientists debate everything from message encryption to cultural contamination risks. publishing open-source templates for cosmic greetings in math, music, and even quantum physics. Then there's the Earthling Project, a global time capsule collecting voices from every culture to beam into space, not just diplomats and astronomers, but farmers, poets, and children. These initiatives prove humanity's best hope might lie in decentralized collaboration, where citizen scientists and hackers can audit the process in real time. The missing piece, a dedicated interstellar diplomacy corps. Imagine a Peace Corps for the cosmos, training linguists, exobiologists, and ethicists in the art of first contact. Universities are already laying groundwork. The University of St. Andrews in Scotland offers a postgraduate course in astrobiology and society, while Arizona State University runs simulations where students role-play alien encounters. But we need scale thousands of experts fluent in xenopsychology and crisis mediation, ready to deploy at a moment's notice, because when the signal comes, it won't wait for bureaucratic committees to draft talking points. The stakes couldn't be higher. A poorly handled first contact could trigger wars over alien artifacts or spark panic that crashes economies. But done right, it could unite humanity like nothing before. Proof that in the cosmic arena, we're one species with one future. The blueprints exist, the passion is there. All we're missing is the courage to treat first contact not as a sci-fi fantasy, but as the ultimate test of our maturity. And the clock's ticking. Every day we delay is another day we risk facing the universe unprepared. From the first tentative beacons sent into the void to the meticulous protocols for planetary protection, humanity's quest to answer the ultimate question, are we alone, has always been about more than just curiosity. It's a mirror held up to our deepest hopes, fears, and contradictions. We've covered the science, how every potential signal must survive the crucible of peer review, how a single microbe from Mars could rewrite biology while posing risks we're still scrambling to contain. We've examined the fragile frameworks for global coordination, those earnest but patchwork UN guidelines, the whispered debates over who speaks for Earth. And we've faced the societal reckoning, religions grappling with cosmic pluralism, economies bracing for shockwaves, and the haunting possibility that silence itself might be a warning. But here's what lingers after the theories and drills. First contact isn't just an event. It's a test, one we've been studying for without knowing the questions. Every decision we make now, from declassifying UAP data to educating kids in interstellar ethics, shapes whether we pass or fail. The universe doesn't care about our borders or ideologies. It only responds to what we do next, so let's not wait for a signal to start the real work. Press your leaders to fund planetary defense and open science. Support educators teaching the next generation to think like cosmic citizens. And most of all, talk not in hushed tones or conspiracy corners, but openly, critically, about what kind of civilization we want to be when the stars finally answer back. The universe is listening. What will we say? Drop your hopes, fears, and wildest theories in the comments, because this conversation isn't just for scientists or diplomats. It belongs to all of us, the only species so far audacious enough to shout into the void and mean it.